Hi, welcome to chapter 3. Chapter 3, we're going to look at the periodic table. So actually, before we get started, if you would, get a periodic table. In the folder for chapter 3, there is a periodic table. You can print it out. And I suggest you do that before we start this little lecture. All right, so let's talk about the periodic table a little bit, where its development came from. Periodic table is actually systematically set up. There's things that are in the same, or elements that are in the same groups, the same periods. There's repeating patterns in both of those things. For example, one thing that when we look down a group, so when I say a group, if you're starting at the top and going down, those are our groups. And if I'm talking about a group, I know that as we go down the group, that the density is going to change and it increases along with the size of our atoms. So if you look at lithium and sodium, lithium will have a smaller atomic radius versus sodium, and sodium will have a higher density than lithium. So that's an example. Here's just showing that same sort of pattern. Here, this is group 3, boron, aluminum, and so forth. If I look here, R is radius, D is density. As I go down the group, boron has a smaller radius and a smaller density. So knowing those trends is super important. So as we go down a column, density increases, and so does the atomic radii. Okay, these patterns were founded a really long time ago. If you look at this, Mendeleev came up with the fact that our elements are arranged in some systematic way, and he was looking at mass, and the fact that it was so long ago, it's kind of crazy actually. All right, so what he did is he took the elements and arranged them in increasing mass. So I'm actually going to go back here. This isn't a great periodic table to look at, but if I go across and as the numbers increase, your atomic numbers, so does the mass. And so that's where he put those together to show that. It's organized actually pretty unbelievably. So we have the periodic table that's organized in groups, like I told you before. So your groups are your vertical columns, and then we have periods, and those are our horizontal rows. All the elements that fall within the same group, they have similar chemical and physical properties. So that's super important to know, just like lithium and sodium. They're both soft metals. They have similar chemical and physical properties. So that sort of is one of the patterns that you'll see in the periodic table. All right, so again, this is obviously a very brief version of the part of the periodic table. But again, we have our periods going across, and then we have our groups going up and down. Okay. So now let's talk about what kind of groups we have. So we have what we call our main group elements and then our transition metals. I'm going to flip over here real quick to the periodic table. Here in my big block here that's blue, these are our transition metals. So our transition elements, but they are all metals. Our main group elements is everything in what we call group 1, group 2. This is group 3, group 4, group 5, group 6, group 7, group 8. So actually, why don't you go ahead and write that on your periodic table? So make this group 1, 2, go past all the transition metals, and then boron will start group 3. And you'll see that those are written up here with an A. And so we're going to refer to those as the like this is group 3. We're not going to look at it in terms of 13. So with that being said, we're not going to apply a group number to our transition metals. So this big block, go ahead and label it as transition metals. Okay, going back here, so our periodic table is broken up into metals, nonmetals, and metalloids. All right, coming back over here, let's talk about that. See this little staircase? Hopefully you have that on your periodic table. If you don't, go ahead and put it there. This is your divider. Everything, well, everything to the left, all this here, they are all metals. And then to the right, like this is where we have our nonmetals. Now, hydrogen's obviously an exception to that. It's not a metal, it's a nonmetal. So that's the only exception to the left of that staircase. Okay, now everything that's touching this staircase, those are what we call our metalloids. Metalloids, so aluminum, silicon, so everything that's touching the staircase. Metalloids have both characteristics of both metals and nonmetals. And so that's how they are different.